Imagine walking alone on a dark path when you suddenly hear footsteps behind you. Your heart skips a beat, your breathing quickens, and your whole body seems to shift into high gear. What you're experiencing is the sympathetic nervous system springing into action through the powerful effects of adrenaline, a hormone and neurotransmitter released by the adrenal medulla. This process begins in the hypothalamus, the brain's command center for homeostasis and autonomic control. Acetylcholine onto nicotinic receptors in the adrenal medulla. In response, the adrenal glands release a surge of adrenaline directly into the bloodstream, allowing it to reach virtually every organ and tissue in the body in a matter of seconds. The hormone binds to adrenergic receptors classified as alpha and beta on target cells, each producing specific physiological effects to prepare the body to fight or flee from danger. One of the most immediate and vital responses is seen in the cardiovascular system. Adrenaline stimulates beta-1 receptors in the heart and dramatically increases the heart rate and force of circulation. This ensures a rapid increase of cardiac output, allowing for more oxygenated blood to reach essential organs like the brain, heart, and skeletal muscles. At the same time, beta-2 receptors in the deep coronary arteries cause vasodilation, further enhancing blood supply to the working heart muscle. Compared to alpha-1 receptors in the peripheral blood vessels, particularly those serving the skin, gastrointestinal organs, and non-essential tissues during emergencies, cause vasoconstriction, redirecting blood flow away from those areas toward the critical systems. This selective redistribution of blood is crucial for prioritizing vital functions like movement, alertness, and oxygen delivery. Additionally, alpha receptors on platelets are activated, increasing blood clotting potential, an evolutionary advantage in the case of injury during combat. In the respiratory system, adrenaline acts on beta-2 receptors in the bronchi, leading to bronchodilation. This significantly increases airflow into lungs, facilitating greater oxygen intake and carbon dioxide removal, which is essential to meet the body's increased metabolic demands under stress. At the same time, adrenaline affects mucus glands in the respiratory tract. A receptor activation typically decreases mucus secretion, clearing airways and reducing obstruction, while beta receptor stimulation may increase thin, watery secretions that help trap and remove particles. These changes maximize respiratory effectiveness and protect the lungs during rapid and intense breathing. Meanwhile, adrenaline mobilizes energy reserves by acting on liver and adipose tissue. In the liver, beta receptors stimulate glycogenolysis, the breakdown of glucagon to glucose, which is released into the bloodstream to fuel muscles and the brain. In some cases, adrenaline can also enhance gluconeogenesis, the formation of new glucose molecules from non-carbohydrate sources. In adipose tissue, adrenaline binds both alpha and beta receptors, increasing fat breakdown, which releases free fatty acids into the circulation as an alternative energy source. Under certain conditions, alpha-2 receptor activity may actually inhibit lipolysis, showing that the balance between receptor subtypes influences the metabolic response. This ensures that the body has immediate access to multiple energy sources during emergencies. The eye also undergoes important adjustments during the sympathetic response. Adrenaline stimulates alpha receptors in the iris dilator muscles, causing pupillary dilation, which also allows for more light to come into the eye and enhances peripheral vision, for dictating danger in dark or uncertain environments. At the same time, beta receptors influence ciliary muscle, promoting relaxation for far vision, enabling the individual to see better and assess distant threats. In conclusion, adrenaline is a master regulator of the body's emergency system through a complex network of alpha and beta adrenergic receptors. It prepares multiple organ systems for immediate action, increases heart rate, redirecting blood flow to muscles, enhances respiration, rapidly mobilizing energy from the liver and fat stores. These rapid life-preserving changes demonstrate the incredible effectiveness of the human body in responding to stress. Adrenaline doesn't just help us survive, it transforms us into faster, stronger, and more alert versions of ourselves in the moments where it matters the most.